I want to start this off really quick just to let you guys know, as you guys can see the chaos behind me, the stacks and stacks of shirts. The shirts are in stock now. They're available on my website, HVACRvideos.com. Go check it out. One last thing too, pay very close attention to this video and also pay attention to the end of the video because I'm going to do a giveaway. This video is brought to you by Sportland. Quality, integrity, and tradition. Today we're working on a bar AC. So there's a little backstory on this. I was here recently doing something else and the customer had brought to my attention that the breaker keeps tripping on this AC. And they said that they hit the breaker and then a few minutes later it trips. So I came up here onto the roof, gave it a quick look. I didn't even open panels up. It confirmed indeed that the breaker was tripped. And I had another technician come out here yesterday because this customer hadn't done any PM work in a while, and had a technician replace all the filters, do a quick coil cleaning, replace all the belts, get the restaurant basically in operational order, you know, somewhat. So we did a light PM, nothing crazy. I didn't have him tear crazy into these things. So we know that our unit should be pretty clean. And we're gonna start there and see what's going on. Great looking electrical panel, huh? Carrier doesn't do a very good job of making it easy to have clean wiring on these things, but still, like, this isn't all their fault. People have cut the zip ties and all that stuff and not put things back. So we need to find a reason for the unit to trip a breaker. That's what we're looking for. So I'm just doing some visual inspections. I haven't tested power yet. It should be off because the disconnect switch is off. Contactors look a little burnt. Just preliminary visual. Nothing's jumping out at me yet. Of course, this is all low voltage. Well, not all of it, but most of this is low voltage wiring. This is high voltage. It's like a lot of this stuff like this was changed in 2013. They did a great job with the wiring on that, just sitting there going into the motor. That's nice. No bushing there to protect the wiring. Okay. Well, we're gonna start with a meter and start toning everything out, checking the ground, seeing if we have any shorts. I've shown this before. I took over this restaurant a couple years back from another company, and this is the kind of stuff that I find. So if you're used to these Carrier units, the compressor should be the same. ZR61, ZR57. Yeah, it's close, but the whole point I'm trying to make is you got to watch out, especially when you guys aren't paying attention to this kind of stuff. You put your gauges on here and it's just, you know, the two stages just aren't running quite right. Something's wrong. It's very common to see someone put the wrong compressor in a unit. You know, oh yeah, it'll be close enough. You know, oh yeah, no big deal. But it makes for a headache when you're trying to troubleshoot weird issues. So you always want to watch out for that kind of stuff. All right, let's go ahead and test three-phase voltage. A to B phase, 208. A to C phase, 209. B to C phase, 208, okay? So we've got 208 volts coming into the disconnect switch. We're gonna test each fuse, the bottom of the fuse to ground. We have no voltage coming through the disconnect. It's working correctly. Disconnect is off. We're gonna put our meter on tone and we're gonna test the fuses. We have continuity through that fuse. That fuse is good. Continuity through the second fuse. That fuse is good. No continuity through the third fuse. We've got a bad fuse. Why do we have a bad fuse is the question. Let's go ahead and test to a ground. We're testing all three legs to ground. Nothing is grounding out. We're going to need to get into the electrical section. We're going to look for any obvious shorts that could potentially have caused a short to blow the fuse. The contactors are not pulled in, so theoretically we could have a direct short on the load side of the contactor and not know it. So what we're going to do is find a good ground. Here it is right here. We're going to test from the load side of each contactor. Which one is the load side though? Should be this side. There, 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 there. Nothing's grounded. test the line side too for giggles. No direct shorts to ground. Okay. Electrical's a mess. Condenser fan motors look okay. At this point, I'm not seeing any direct shorts to ground. We're gonna have to change the fuses and fire this guy up. Just kind of see what happens. Test all the motors and everything. Okay, so we know we've got no voltage here. Still gonna use a fuse puller though. I've shown this a bunch of times. It's just, I got it from like Home Depot. It's made by Ideal, I think. So, and I've got some new fuses right here. They're usually a little bit harder going in. Disconnect things are pretty loose. Might have a problem there. Okay, fuses are in. They're just standard 60 amp fuses. I always leave extra fuses too. We've got 3 more for later. All right, at this point we're going to power this guy up and see what happens. I'm not going to put any panels on yet because I want to catch any potential problems. I want to see the blower motor start. I want to see the condenser fan motor start. Then once it's running for a bit, I'll put the panels on. But I just want to see the initial startup and see if we see any major problems. Power's going on. All right, so sometimes they do that weird little initial startup. We're going to test to make sure we still have 3-phase coming in. Yeah, we didn't blow any fuses or anything. Alright, so let's go ahead and jumper the unit out and see what we can do here. So I'm going to test the indoor blower. We're going to jumper out G to R. Don't short it out on the unit. Yeah, I thought I blew the fuse or something, but I didn't. I touched the side of the unit. We still have 27 volts. So my indoor blower motor is not pulling in, and it should. Really cool thing that most manufacturers do, if you want to know what's what as far as the contactors go, there's typically a legend down here. So right down at the bottom of the schematic, you see this schematic, okay? Down here in the bottom, there's a legend. And it says ignition control board, IGC, IFC is indoor fan contactor. And then you have C1 and C2, outdoor fan relay transformer and compressor lockout 1 and 2. Just look at the lettering. So IFC, and if you go up here to the legend, it'll tell you IFC indoor fan contactor. So my indoor fan contactor is this guy right here. We need to test voltage to see if we've got 24 volts going to the coil. If I can do this. We do not have 24 volts going to the contactor coil. So we need to figure out where the potential problem is. So we know, let's test from common to G. Oh. It's weird, it doesn't have 24 volts. What's going on here? We've got 24 volts coming out of the transformer. Test up here. So C to R, I have nothing. Weird. Let's make sure that I didn't blow this fuse when I shorted out the. No? Yeah, the little breaker's not tripped. So why do I not have 24 volts at the R terminal? I should have 24 volts right here, and I don't. That's weird. gasket lost it. I probably blew the fuse on the board when I shorted it out. Yeah, that's what I did. So if you guys come over here. So when I was going to put the jumper on, I accidentally touched the alligator clip to the wall. And we've got a fuse on this board. And we've got 27 volts across the fuse. So I shorted it out. That's one of the downsides to using jumpers. Here's the fuse right here. I blew the fuse when I was testing it. So I gotta go grab a fuse from my van. All right, I got 2 fuses, one to put in the unit and one to leave as an extra. Well, there's the indoor blower motor. So I went ahead and replaced the fuse and then left the spare for the next guy. Indoor blower's running. It looks like it just cycled off, but we can jump it out for real now and hopefully not short out everything. There we go. Okay, now we got a jumped out indoor blower. We need to pop our head in here and see what this thing's allowed to run. And we'll put the panel on and take a current draw reading on the blower. With the panel off, the blower doesn't have any restrictions on it. It really doesn't have any pressure drop across it, and the current draw is going to go up. Okay, so you don't get a valid current draw reading on a blower when the panel's off. All right, so notice we're at 9.3, 9.4. Now I'm going to put the panel on and we'll test it then. All right, now that I put the panel on, look at the current draw. 7.5. So you see how much it drops. So remember, when you're testing current draw on motors and stuff, you need to have the panels on. Okay, so now it looks like we staged on first stage compressor. Both condenser fan motors are running. There's definitely some massive shaking going on in here though. You hear like something's just rattling up a storm. Oh, both compressors are running at the moment. So both compressors are running, both condenser fan motors are running. I need to get a current draw on the compressor, on the fan motors. And then we need to get this panel on. This jumper really isn't needed anymore because it automatically cycled on by itself. Okay, we're testing the condenser fan motors. We have an aftermarket motor that's allowed to run 3.2 amps, and then we have a factory motor that's allowed to run 1.42. So this is the aftermarket, it's running 2.6, and this is the factory, it's running 1.4. So the condenser fan motors are not over amping, they're fine. Whether or not the capacitors are good is a good question. We're just gonna let this guy run for a little bit. So far I'm not seeing something that jumps out at me, everything's operating, but I don't like the vibration of the unit. It's shaking a little bit, making a funny sound. All right, well, I'm gonna watch it for a little bit longer. All right, everything is running. So far, the condenser fan motors and the blower motors not overamping. We're gonna check the contactors. Check voltage drop, nothing. 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 So I don't have any voltage drop across my contactors. We're gonna get out the thermal imaging camera and see what they look like. I need to take the cover off of this one though. It doesn't look bad inside. These ones look burnt for sure. And then when we get the thermal imager out, we'll look at the disconnect switch too. Okay, we are operating. Look at this contactor right here. It's definitely warm. Let's move on over to this relay for the condenser fan motors. Right there's the relay. Definitely a hot spot down at the bottom. Okay, and then we're going to go to the compressor contactor right here. I mean, they're all nice and warm. I don't see anything too crazy. Just look at that board. Relays, capacitors or something in the board's pretty hot too. All right, we're going to go over to the disconnect switch and see what that looks like. Pulled the protective cover off of the disconnect switch, and everything looks to be running pretty evenly. I don't see any big temperature swings, anything that's scaring me there. All right, this unit is operating. Disconnect looks okay. I don't like the vibration that the unit has, and it almost looks like those knives aren't completely making contact. Let's see if they move at all. No? Sometimes when the disconnect, I'm using an insulated screwdriver, by the way. Sometimes the disconnect knives don't make good contact, but I don't see a problem there. Let's test, nothing's loose. Everything's good. There's no overheating wires. I still don't like the vibration that the unit has though, but it's running. And I'm not seeing anything. I'm gonna let it run for a little bit longer and see if we can catch any problems. I'm probably gonna gauge up on it too. All right, we've got a dilemma here. First off, we had a blown fuse. I don't know why the fuse blew, okay? But just using, you know, reasoning and looking at everything, I don't like these contactors. They're all kind of burnt on the contacts, kind of pitted, charred. I'm not getting a voltage drop across them, but I just don't care for it. I also don't care for the vibration that the unit has. It's just got a really strong vibration, and that vibration happens when the condenser fan motors turn on. This condenser fan motor is an aftermarket motor, and there's a vibration in it that I don't like. Also, there's a slight vibration in this motor too. In a perfect world, I'd like to change both of these condenser fan motors, replace all of these contactors, and redo the wiring in here and eliminate these wire nuts. So basically come from the disconnect with a home run right into the top of the contactors. I believe number 8 wire. This is too big. This is like 6 or 4, and it doesn't need that big. It's just a 60 amp unit. Number 8 should be plenty. I'd like to come in with number 8 and do that, but whether or not the customer is going to want to do that, I don't know. So at this point, I'm not going to change the contactors because I'm probably going to quote a big picture repair here. Replace both those condenser fan motors, go back with factory, all 3 contactors, and we'll change the condenser fan motor relay also. That's going to be my plan here, but we got to see what the customer wants to do. So what I did was I disconnected the jumper wire for the compressors and just left the indoor blower motor, and this thing still has a vibration. It definitely intensifies when the condenser fan motors turn on and starts rattling the panels, but look at that liquid line. I mean, it's still vibrating pretty good. So we got a couple things going on here, and this is actually rubbing against the discharge line back there, or the liquid line, so that's a potential leak point. But yeah, it's in the blower motor too. This unit's just all beat down. Let's open that up. It's probably, I remember that belt was kind of wobbling a little bit. Killed the power. So the belt is a little bit loose. It can certainly be tightened. The pulley doesn't look bad though. I mean, it doesn't feel like it's starting to fail, but I don't think it's time to change it yet. There's nothing wrong with that. It's not aligned though, but like every carrier, they're never aligned, and they never line up perfect either. The motor plates always shift. It's always a pain in the butt to get these things lined up perfect. But I'm definitely going to tighten this guy up. Get in here, this blower wheel is caked with crap. Big old chunks of stuff in there. That thing's dirty as heck. Look at that, big old chunkers. So in my quote, we'll pull the entire blower assembly out, clean it, and hopefully that balances it out. And then when we pull it out, we'll line up the pulleys and all that stuff too. I'm gonna have to have a talk with my tech that was out here putting the belts on, but I got this guy snugged up nice and good. You're not gonna see the belt wobble anymore. I don't know if this is gonna intensify the problem though, because if the blower wheel is out of balance, it's definitely dirty, and we tightened up the belt, it's gonna vibrate more. So we'll have to see. Yeah, it's still got a pretty mean vibration to it, man. It's kind of a mess. So we're gonna have to definitely talk to him about that blower. We need to redo that. I ended up loosening the belt back up so that way we can reduce the vibration a little bit. I'm torn though on what to do here because it's a lot of work to pull that blower assembly out. And we're gonna have a lot of man hours. I'm gonna have 2 people here. We're gonna pull the top on the unit. It almost makes me wonder if it's just better to go ahead and have the blower wheel replaced. We're gonna go through all the work to get it out. I mean, when you figure the labor is going to be the same, the amount of time. Well, I shouldn't say the materials though. If I was to replace the blower wheel though, you'd change the bearings too, and you might as well change the shaft. So it's going to be a considerable amount. I'll basically leave it up to the customer. I could pull that blower assembly and have it rebuilt. That'd probably be the best way. We'd save on labor that way too. But I still don't like these condenser fan motors, and I want to get rid of that aftermarket motor over there. I'd like to clean up this wiring, replace those contactors. I just feel bad though, but it's one of those things where my gut starts making me feel bad because it needs to be done. The contactors need to be changed, the wiring needs to be fixed, the blower needs to be rebuilt, and we need the fan motors, at least the one fan motor for sure, but they're both vibrating. But I just hate spending all that money on this unit. But I shouldn't feel bad though. I mean, my job is to tell the customer what's wrong, you know? All right, this is my first stage. It's not looking bad. The superheat's a little bit high, but we'll dial that in when we get the blower assembly cleaned. I mean, the unit's performing pretty good though. Got a decent split. Airflow's half-assed decent. Again, we're gonna change everything. So I just wanted to make sure there was nothing too crazy going on. We're gonna jump on the second stage. So the second stage, you know, it's kind of looking about the same. Pressures are half-assed decent. Superheat's still a little bit high. Everything else is gonna stay the same. So I'm not too worried about the refrigerant charge too much. I might have a little bit of room to add or remove just a little bit, but everything's looking pretty decent on this guy. And again, we'll make more changes once we fix the airflow and clean the blower assembly. You know, I don't have hopes that they're going to approve this quote because the unit is operational. I mean, they're probably going to wait until it completely dies. This is one of those things where I can't give them an absolute, you know, this is why the fuse blew, but these are the problems that I found. The refrigerant pressures, as I showed you guys, they don't look horrendous. I mean, you know, superheat's a little bit high on both stages, but compressors are functioning. Again, keeping in mind that those compressors are potentially the wrong compressors. So that kind of messes with everything. But other than that, I mean, you know, we're just gonna give them a quote and see what they want to do. But that's it on this one. Well, they actually approved the repair. I modified my quote idea a little bit. So what we're doing is we're rebuilding the whole indoor blower assembly. And then we're gonna redo a bunch of electrical. We're replacing the one condenser fan motor that's an aftermarket fan motor. We're gonna leave the original OEM one right there. I basically told them that I couldn't find a reason for the breaker to trip and that my best assumption would be it had to have something to do with that vibration. I told them we gotta fix the vibration before we can go any further. So that's what we're gonna do. I got another tech coming with me right now. I'm just disassembling the unit. We're gonna start pulling the top, pulling the fan motors, pull the blower assembly, get the unit top off, got the blower assembly out. Just gonna start cutting away. I confirmed that the blower wheel's the same, so I'm gonna just cut off the existing shaft. I have a little cutter that can hopefully fit in there. I picked up this little die grinder, and I'm hoping it'll work in a situation like this. I'm hoping, we'll see. So my little grinder's not gonna work, but I got my Sawzall right here and we'll cut it. But before you cut anything, you always double check. The blower wheel's right, the shaft is right, because once I cut that shaft, we're done. And then I have the bearings, so. All right, we're gonna give this guy a chop. Baby steps, got the shaft cut. The blower's gonna pull right out of the bottom of the blower assembly, but always pay extra close attention to what direction you took it out. You know, that way you don't have to think too hard when putting it back in there. So just slide the new one in, same way. And then before I put the blower in, we're gonna clean this whole blower assembly. I brought a hose up, we're gonna get it all rinsed out. All right, we build this slowly. I'm taking the adjustable motor pulley and I went ahead and matched the size, closed it down and tightened it up. We're still going to amp the motor and make sure we're not over amping, but I try to match the exact size from everything that was on there so that way we don't mess with the air balance. This replacement pulley has a bushing. In order to tighten these bushings on, what's going to happen when you tighten it, it's going to pull the pulley onto the bushing. So oftentimes what you want to do, now I'm going to make my alignment with that pulley because I can adjust it more, but oftentimes what you want to do is you want to push the pulley on a little bit further than you're comfortable with, about 1/8 of an inch, 1/16 of an inch, somewhere in there, because when you tighten the bushing, it's actually going to pull the pulley out to its final resting place. So again, being this is a carrier, guys, you never get these things perfectly straight. These things are always wonky. So I'm gonna do my best, but I'm not looking for perfection. Once you get it where you want it, what you're gonna do is you're just gonna tighten them down evenly, a little bit at a time. So a little bit on this one, a little bit on this one, and back and forth, nice and slow. You don't wanna over tighten them because you'll break the bolts off, just until it's snug. All you're doing is pulling it tight up on the bushing. The key being in there is all gonna clamp everything down on the shaft, and it'll all be permanent. As usual, I got way in over my head. Well, not over my head, but just one thing turned into another. As I'm undoing the economizer wiring, I realized that the compressor lockout boards were completely bypassed. So I'm gonna take a gamble and assume they're still good, and we're gonna wire them back in. And then we're going ahead and getting rid of all that. I think it's number 6 wire, because that's too big for this. This thing, 60 amps. So it's got, I think that's 4 or 6 coming in. And we're gonna come out with 8. Direct shot into the contactors, no more wire net. So I'm just going through trying to figure this wiring out first, simplifying these pressure controls because there's just a mess. We'll shorten them up, wire the lockouts back in, then we'll start changing the contactors. All right, we're just about done tidying up the electrical. I ended up doing a home run from the disconnect switch. Now, I was saying number 8 wire and I was incorrect. I ended up using number 6 wire, okay? This does have 60 amp fuses in it, but it's not running 60 amps. The unit is only running like 53 amps. So I went ahead and ran number 6 wire direct here. I did have to use a wire nut for the ground because I didn't have the little fitting for the ground wire, but everything else, there's no wire nuts, goes directly into the contactors. I just changed the orientation of the contactors to the lug style. So I think I did everything right. We're gonna put the top back on, wire in the condenser fan motors. We also went back to a dual run cap, and we're gonna go dedicated wiring right to the run cap now too. So, all right, we got the top back on. It's, you know, as clean as it can be. It's not perfect in here, but I shortened the condenser fan motor wiring so that way it's not all long. Cleaned up the pressure control wiring, shortened all that. Hopefully I didn't screw everything up. We're trying to see if we have a condenser fan motor relay right now. I don't know if I have one of those or not. We just got to put the disconnect back, and we're gonna get ready to fire this guy up. So I'm gonna start it up. Because I changed up the wiring and I don't have color coordinated wiring, I got to just go ahead and bump it and check the rotation of everything. So I disconnected the R terminal so the unit won't fire up. We're gonna hit this guy right here. Hopefully it doesn't blow up. Nothing blew up yet. We're gonna do a double take, check voltages, and then we'll just bump them one by one. All right, we're gonna check phase rotation. I was thinking about it and I can check it here. So here's what we're gonna do. Line 1 and 2 is right here. Okay, and then it says line 3. And it says line 3, 2, 1. So our phase rotation is incorrect, and we can verify it by bumping the blower. I'm gonna bump it right now, and that's the wrong direction. The blower should be running the opposite direction. So we are going to reverse rotation at the disconnect switch. All right, let's go ahead and turn the disconnect switch back on, and we're gonna test phase rotation again. I went ahead and changed that condenser fan motor relay too, so. One, 2, and then line 3. Line 1, 2, 3. Phase rotation is correct. So if I bump this contactor, the blower should be turning counterclockwise. And it is, counterclockwise. Okay, so we're good on that now. So now we just gotta test fire everything else. So I'm gonna fire up a compressor and listen to it run. That sounds incorrect, so we got a phase rotation issue there. Let's fire up the other compressor. That's incorrect. So I screwed everything up. So it's fine though, we just reverse it right here, and then we should be good. All right, let's fire these guys up and listen. Much better. Much better. Okay, compressors are good, indoor blower's good. We're gonna go ahead and wire this back up to R and then test all the functions. I literally rewired this entire unit, pulled out the economizer, so the odds of this thing working here is very slim. There's going to be problems. So indoor blower's running. We're allowed to run 10.2 amps for the indoor blower motor. We're running 9 amps, so we're good on that. We're going to wait for first and second stage to call. They should call here any minute, and then we'll test the condenser fan motors and all that. One of the condenser fan motors is running 1.42. That is the new one. It's right at run load. And then the other one is running 1.3. That's the old one actually. But they're both within spec, running properly. We're gonna let this guy run for a while, and then I'll grab the thermal camera and show the contactor difference now that I changed them. All right, we are back up and running. It's been running for about a half an hour now. Let's scroll over here. We've got nice, good, even flow across that contactor. That is compressor number 2, I believe. Okay, let's move on over. There's my condenser fan motor relay. That is definitely calmed down. Okay, compressor number 2. This is the contactor, and indoor fan contactor. We're looking pretty decent. This is my first stage. My superheat's a little bit high, but I'm really not gonna mess with it because everything else is falling in line pretty good. So I really don't wanna mess too much more stuff. We've got a 20-degree TD. This is the second stage now. We're still running a little bit high on the superheat, but I have a theory behind that. Everything else is looking okay. My head pressure's a little bit high on my second stage, but let me preface some things. Number one, this unit has the wrong compressors in it. Remember in the beginning of the video I showed that it has the wrong compressors. Number two, the suction line temperature. The suction line is not insulated and it gets hit by the sun. So I'm not too concerned about that superheat. I mean, it's right there. But the temperature clamp for the suction line is literally in the shade. I mean in the sun, because the condenser fan motor holes. Everything else is looking half-ass decent on this. I'm not gonna sweat this one right now. My head pressure's a little bit high, but I saw the inside of the condenser. It's clean. I'm not gonna mess with it too much. You can see we're moving. The target's coming back right now. So, all right, the vibration in this unit is pretty much gone. I put that. You can see that new condenser fan motor that I put in over there is sitting in the shroud like it should be. I mean, this unit has the slightest vibration. It's so much better. We replaced all the contactors, the condenser fan motor relay, rewired the unit, eliminated a bunch of BS, made sure there was no electrical shorts. It's so hot outside that I have to power it down to take off the panel or it just shuts off on lockout. But yeah, both condenser fan motors are doing what they're supposed to be doing. But again, like I said, one of those, if not both of those compressors are the wrong compressor. It's funny, they changed them like 3:14:17 and 4:12:17, like right after each other. Silly. Looks like they were having a hard time with that braze joint right there too. But I'm gonna wrap this one up. Everything's looking good. The lines aren't shaking anymore. I tried to support everything. This is all safe and zip tied, so that way it won't rub up against anything. Indoor blower's good. Customer's gonna be very happy.
All right, we can't always be perfect in these videos. I make mistakes. You saw that I shorted out the alligator clip. I blew the fuse. I never actually found the exact reason that caused the fuse to blow in the first place, okay? Why the breaker was tripping, well, I know the breaker was tripping because we had a line 3 fuse blown. Control voltage was still being sent to the thermostat. The thermostat was still telling the system to turn on, and then the unit would run in single phase and trip the breaker. So that's why the breaker was tripping. But as far as why the fuse blew in the first place, that's a good question. I had to go to the customer with all the information and just tell them, look, I didn't find the problem that jumped out at me, but here's a list of things that's wrong with this unit, and we have to fix these things first before we can advance any further in our troubleshooting, okay? So with that being said, I found the vibration. It was caused by the indoor blower assembly being out of balance, and the second condenser fan motor that was an aftermarket motor was also causing a lot of vibration too. I talked the customer into letting me take care of those problems. We eliminated the vibration. Again, I looked at everything, you know, with the customer's best interest at heart, and I said, look, it's going to take me so much time to pull that blower assembly out and put it back in. It seems like a waste to not go ahead and change that wheel, because what happens if the wheel was damaged and I pulled the whole thing out, then put it back in and it was still vibrating, and I wasted, you know, many man hours for 2 guys to pull that thing out and put it back in my opinion. And I gave all this information to the customer. It was going to be in their best interest to go ahead and have me replace the blower wheel since I had it out, put a new one in, new bearings, new shaft. Then we were done with it. And then we also went ahead and changed the condenser fan motor. I didn't like the wiring. I didn't like the contactors. I went ahead and redid the wiring as best as possible. Because the system's economizer was not hooked up, I went ahead and ripped out all the economizer wiring because it wasn't being used in the first place anyways. If the customer ever chose to go back in and put a new economizer in, I would certainly just run new thermostat wire to it, okay? So we got them operational. It was an extremely hot day that day too. It was 105 or 108. I can't quite remember, but it was ridiculously hot on the roof. So I was hurting at the end of the day. Also on that, the indoor blower assembly, the pulleys, I went ahead and changed the pulleys because I had it all out, and I just figured, you know what, I'm gonna just go ahead and get those things on there too. They weren't completely bad, but they were starting to wear. Went ahead and took care of that. Changed the contactors because they were starting to pit, and you saw the heat signatures. They just weren't quite even with those. The compressors were another thing. When I was showing the refrigerant pressures, I was basically like, look, this unit's not going to get too much better because we knew that someone had put the wrong compressors in there. Now, which compressor is wrong, I don't know. I didn't dig too much further in there. I know that that's a 10-ton unit, so they're close, but they're not 100% right. They're 400 BTUs off here, a couple hundred BTUs off there, give or take a little bit. It's always important to go back in with OEM, or if you're going to do an aftermarket, make sure it's the right unit. Don't just slap in two different compressors because there's going to be a difference there, okay? We often run into those kind of problems, and you have to know when you're having a lot of issues diagnosing or troubleshooting something, you have